Good day to you. This is Adam Galactic bringing you another science presentation. In universal geometry, we're getting down to the nub of things. In the last lecture, we were discussing the nature of the proton, and the proton is indeed where to begin in order to understand physics and any of its aspects if one is looking for universal scale understanding. Of course, that is the premise of these presentations that I'm giving out on YouTube, and so we begin again at the proton. Just to recap what we discussed in the last lecture, it is necessary to summarize to maintain continuity with what went before, and this will be a multiple lecture series because this, of course, is the most difficult problem. I prefer puzzle, but it actually could be elevated to the full-scale level of problem because this is it. This is what physics wants to know. What is universal structure? Beginning with the building blocks, the reason for doing this in the sense of an approach to understanding of the universe, that is what we would call the heavens or the cosmoses, the cosmos, the universe, is that the building blocks consist of things such as the proton, the electron, and the photon, which dictate every single thing that we know about the universe. And here's why. The photon, of course, is the unit of light. And obviously, we get all of our information about the deep space heavens from light. You have to throw in something else, there's gravity. And of course, the rotational speed of galaxies has been computed according to a standard formula for gravity, so it is important to understand what gravity is. And we now know, as of the 20th century, that the way to understand gravity is to understand the proton. So that leaves us with just one stray particle, the electron, which we're going to talk about today, because it is unique in a duality that it forms with the proton. So let's begin by just recapping what we know about the proton. Some of the statements that I'm forced to make will sound grandiose because we're approaching a paradox in an effort to solve it. And in an approach to a paradox, it is necessary, as I indicated, to devise an anti-paradox. And that's somewhat random. It goes into the cloud. It's part of the inductive phase of science. But no one has been able to do it yet. And what is it? It's to understand universal structure, but with specific applications such as understanding light propagation, which is quite necessary if one is trying to understand the fundaments of the universe. How does it tick? What makes it work? We have several fundamental questions which are paradoxical, but beginning at the proton is quite logical. It leads us into a consideration of the electron, and then from the electron we can then approach an understanding of the photon, the three main particles. Now, the proton is also extraordinarily significant geometrically, and here comes the first grandiose statement. It can be said to be the center of the universe. Now, obviously, that's not obviously logical. And we discussed this in the previous lecture, but it is so germane to the topic, it's so central to what we're trying to understand, that it's worth a brief recap. The universe is one term which is somewhat undefined because it has an unbounded edge as far as we can tell with our instrumentation, or indeed with our geometrical mathematics. We simply cannot conceive of a physical edge. It appears to be infinite. So the universe is already a term which contains a paradox. Now, the center of the universe, therefore, cannot be found. And this is a duality, a very obvious duality, but it's worth bringing out explicitly now because there's two paradoxes. They would seem to be related. So to say that the universe does have a perceptible center is something worth pursuing, although there is another paradox involved, namely that it's not a single, what we would call a geometric point. And so just to bracket where we're going in our further discussion of the proton to get at the structure of the atom, the proton bends space, we can say that. And so we determined that it is proper to say that the proton is a spatial particle, virtually redundant, but it becomes obvious that we should say it that way, spell it out, that it is a spatial particle because of its effect on space. And that has a reciprocal way of saying it, which is also worth stating explicitly. If you're trying to solve a paradox, you have to be very explicit in what you're saying, because at any place in your logical sequence, you may surmise or intuit where something might have gone wrong. In other words, an assumption that had been made virtually forever may have another aspect. And that is indeed what I've discovered. So when I say that the proton is the center of the universe, this is a limitation of language. Let's just consider how we consider what a center would be. In free space, just cosmic space, empty space, plain, old, ordinary space, to have a center would be a spherical center, obviously, and that is what a proton is. And the proton demonstrates that it is actually a spherical center because of the geometry in space that occurs in proximity with the proton. We discussed that, but let's just summarize it. The position of a proton upon analysis of the atom is so obvious that it may not be understood as being profound, that the proton is the center of every atom. And there is no such thing as an atom without a protonic center. Henceforth, just for simplicity, as science has done in its research, I'm going to be speaking of one proton. This would be simple hydrogen in the case of a single electron, which is the most common element in the universe, about 99%, is hydrogen, which has several composite forms due to the possible presence of one or two neutrons, in which case it has a different name. Deuterium is a single neutron with the proton, and tritium is with two neutrons. These are somewhat unstable. The most natural state of hydrogen is one proton and one electron. And then what we have discovered in science in the 20th century is that this typical of an atom system pared down to its minimum, one proton and one electron, the electron forms a spherical shell around the proton. The reason we are so confident that that is the same thing as gravity is because it's a centripetal force. And in spherical space, there are only two proper forces. One is centripetal, which goes in towards the center, and that is the definition of gravity. And the opposite direction would be going out. Well, a moment's thought, what would be an example of centrifugal force in the universe, a physical, intrinsic, centrifugal force. There would have to be such a force in order to balance centripetal force. And Emmy Noether is one of the pioneers in proving that forces in the universe must be symmetrical if they're conserved forces. If there is a force, there has to be an anti-force. And now we've gotten to a binary dichotomy, which we're well aware of. Plus and minus charge is this kind of a dichotomy, often called a duality, although that has more than one meaning. Dichotomy has an ambiguous meaning if you look it up, but it does have an application here as a specific kind of duality. It's a binary split, but the two components of the two things are related. They're related to each other. And in the case of plus minus charge, you can't have one without the other. They can be isolated, so you can build up a charge, voltaic charge or static charge. And so that's not exactly what the dichotomy is. But the exact dichotomy, or more exact dichotomy, is the proton and the electron. So we're going to be discussing the electron today and see if we can get forward and discuss the photon. So geometrically, we're speaking of the entire universe, but we're looking at the center first. We've already discussed the edge, and both of these are paradoxes. Now, in the case of a sphere, if the universe is spherical, it's obviously hyperspherical. And I've already proved that, and it's strongly surmised, although getting the proof of hypersphericity has been elusive. And I know that part of the reason for that is we're still using linear algebra, the linear metric system, which simply cannot address curvature, except by artifices and contrivances such as complex numbers, the calculus, and of course the sine-cosine relationship. Those are our three primary tools for probing curvature. But if you begin, as I discovered you can begin, with a different geometry, with a different basis, based on sphericity, that it's consistent and coherent, and remarkably, and in fact miraculously, it's also closed. The line is not closed, and it cannot be closed, except by realizing that the line, that is linear space, which can be extended to planar space with 2 lines, and cubic space with 3 lines, that's what Einstein used, that in itself cannot directly address sphericity, or what's called curvature in any linear dimension, cannot be extracted, because all you can do is use a grid, whereas the curve is continuous. The lines are not. And in fact, the line is not continuous in itself, even if it's bounded finitely, even artificially with plus and minus infinity, which is done in calculus. Nevertheless, the numbers on the line have to be quanta. They have to be quantized or they wouldn't be numbers. The definition of a number is a point on a line. And so curvature does not conform to that, but it can be composed on a 2-component number, for instance, for a circle. That, remarkably enough, can also be done on a sphere, and you know all about this already from longitude, latitude coordinates for the surface of the Earth. However, the reason, and that should raise a question in your mind, because if the circle is parameterized on 2 linear numbers, how can the sphere also be parameterized on 2 numbers? Because it would be ambiguous which is... Shouldn't you need 3 numbers for a sphere? Well, that also has been done, of course, with x, y, z. And that's the Pythagorean parameterization of the sphere. But the sphere can also be parameterized on 2 numbers. And here's the secret, which I have never heard actually explicitly stated, but with some thought you can figure out why the sphere can be parameterized with two linear numbers. It's because they're not linear numbers, they're curved numbers. When you compute longitude, it's actually on the basis of the equator. Yeah, it's of course well known. And then the latitude are basically smaller and smaller circles. The longitude circles are all the same. It's just basically you rotate it. And that would make a 360-degree rotation, or 180 degrees with a plus-minus valence, which is how we divide up the Earth for geographical locations, is east and west, all the way to the anti-meridian, which is called the International Dateline, for reasons which I think you all already know, or it'd be good homework for you to think about that. Why was that done? There's a very good book on why that's done. Well, that's outside reading. I'm sure you could find out if you haven't already. Why we use longitude and latitude so effectively, it's because they're curved numbers. I could say more on that, but we're actually going to figure all of that out from the basis up, because it turns out a really remarkable fact about geometry is that if you begin your system with a line, which we have and we continue to use to this day, Albert Einstein uses a linear formulation for gravity, time, space, and quantum mechanics is composed, well, not so much, there's a twist to it because you have to get at curvature with something. And so in quantum mechanics, complex numbers are used, which are not linear numbers. Using a special form of conjugate algebra, you can use the square root of -1 as one of the two basis axes to make pseudo-linear space. It's called curvilinear space. You need another artifice in order to get the continuity, which is still artificial no matter what you do with linear basis. But because you've made the vertical axis imaginary, which simply means the square root of -1, you actually induce a circular function with the use of a basis axis whose metric is the square root of -1 instead of the usual 1. And by doing that, you can utilize another discovered fact in mathematics, a very special number called e, called the natural logarithm, and by using e to the, for instance, pi power, it's e to the theta power. It's e to the angle power. And that actually makes a perfect circle to the limit of the calculus by using e as the natural logarithm for the relationship between 1 and the square root of -1 on the base axes. So that is a summarization of the limitations of linear algebra have been well delineated and brought out in my prior lectures, of which there are now approximately 390. But what we actually want and need now, and I really am the first man to intuit this to any effect, we can use a different geometry. And nobody ever thought of it. Nobody ever thought of even trying it, for reasons which I've carefully delineated in prior lectures, why nobody could see this or even imagine that it could be done. But it can be done. We're going to need spherical geometry in order to see the quantum. And so we're heading in that direction now. At the beginning of this will be a long lecture. All my lectures from now on will be excruciatingly long. In other words, over an hour. Because that's my rhythm. And it's based on a combination of things that I have discerned or given into, whatever the case may be. But you're stuck with it. You could always watch this in 2 or 3 parts if necessary, but I must continue through. So we begin at the proton, realizing that it represents a center to the universe because it bends space. It bends space spherically. This actually explains a lot, that the proton bends space spherically. One aspect of that is the curvature of space is felt as a force for a long time called pseudoforce, and still is in many contexts, because it is possible to say that it's not a true force because it lacks one of the characteristics that every other kind of force has. Centripetal and centrifugal forces are considered to be passive. Now, in the case of centrifugal force, you can generate centrifugal force, for instance, on a merry-go-round, or one of those things that you used to jump on that would throw you off because of centrifugal force if you don't hold on. So that actually can be seen from experiments that you can do on the playground. But centripetal force, that only occurs intrinsically in nature because it pulls things in. Well, that's very strange, isn't it? That there's a force in the universe that pulls in spherically. There's Albert Einstein, who discovered that the right geometric way of looking at that is that the proton is curving space. Except Einstein was not talking directly about the proton. But he was indeed talking about the proton because gravity is nothing more than an integral of many protons, all of which are bending space. But because the protonic systems, atoms, they collect together because of the mutual force of gravity, or at microscale, the mutual attraction of particles under some circumstances. This centripetal force occurs at two scales, but it's still protonic force that causes the curvature of space, which is the manifestation of centripetal force. Now, I say that it is a force, and it's easily proved that it is a force. You may think one way or the other because you may think that you know, but it actually is something. It's not exactly a paradox, but it superficially is a paradox. Because if you throw something out with centripetal force, it just keeps going. If there's nothing else, if it were a whirligig in empty space and something flew out from it, it would just keep going. What we say is, barring any external force, it would just continue to go. That's one of Newton's laws. But it's not the same case going in. Now, it is said that the supermassive black hole actually transcends that boundary and collapses to what is called a singularity. Let me just alert you to something. That is a mathematical contrivance. It's actually a geometric contrivance on a mathematical error because of the misunderstanding of the nature of the linear grid system that we use. The singularity, so-called, which is at the center of the so-called black hole, is considered to be an inversion, actually, of everything, is an inversion of anything that we understand. Which already must sound suspect when I describe it that way, but this is strongly accepted because it's the only theory that the supermassive black hole has a center that's under such tremendous gravitational pressure that it inverts. And that's simply undefined. Well, that's because zero is undefined. It's the retraction of all of the spherical space under the influence of supergravity. It's gravity that's so great that it is computed to transcend a limit. And this is the nature of the mystery of the supermassive black hole, leading to such an incredibly extended system of really what amounts to nonsense. Because the entire perception, the entire conception of the center of a supermassive black hole is based on a fundamental misperception of what space is. So all of that is to say that we're leading up to macroscale considerations, but we must begin at the proton. And here's why. Here's one reason why we are very strongly encouraged by the structure of logical progressive insight to begin at the center, because we can localize it. We cannot localize the edge of the universe, but that is the reciprocal problem to this one. So cracking this secret gives us a direct perception of how to integrate the edge, which has been the goal. One of the main goals is to somehow explain physical outer infinity. But this is the right way to get at it, because paradoxes tend to come in pairs. I have a suspicion, although I haven't pursued this, that all paradoxes are in pairs. But one thing you can say about a paradox, and this would have to be a true paradox, is that to solve it you need the anti-paradox, whereby you achieve a relationship that you could not perceive without extending your mind. So in other words, you're trying to transcend some mental barrier, but then you need a safety net, because if you transcend your natural mental barrier, that is one definition of insanity. So the proton is well worth study. Of course, industrial science agrees fully for its own reasons, but we're vastly interested in the results that any they have the tools to explore the proton, and so we benefit from that no matter what the intent of industrial science is in getting this information or understanding. So what has been discovered, the absolute cutting edge of this level of physics, is the 3-quark system for the proton. The proton is now known to be a mechanism, that it's not just a Democritus atom. It's not just a BB. It's definitely not a point. And that is where we should begin. The proton is not a zero. And in a very basic sense, all protons are the same. They can be artificially increased with kinetic energy, I believe it's called, in a cyclotron, by accelerating it. That, of course, adds energy to the proton in terms of its velocity. But in just dealing with atomic structure, the proton is never considered to be moving, because in local space, the atomic space, it's not moving. But the electrons move. And that is a profound difference between the behavior of the proton in the atomic system and the behavior of the electron. Okay, so let's go a little bit into spooky land, spookhafte. And consider the two particles. This would be defining the particle in a new way. The basic definition of the particle is the proton, but if you add one word, it's much, much better. The proton is the and the only spatial particle, for all the above reasons. It occupies a center in local space. This would be the space of the atom. It's always at the center. And the electrons always occupy shells, spherical shells, arranged around the proton. If it's one proton, it's just one shell, because it's just one electron. So that's actually quite interesting. Geometrically, it's quite a coherent system. It's a spherical system at the center of the universe. So let's make sure we just recap why we can say that. Because there is a hitch in thinking that. So to complete all the above threads right now, the universe does appear spherical to us because it's uniform in the spherical direction going out. There doesn't appear to be any appreciable difference in the distribution of matter in any one direction. And that is significant because it means that there's no center to the system. There's no geometric center to the universe. That's looking at it one way. And the fact that the universe has no center directly implies that it has no edge. So no matter which paradox you begin with, you encounter the other paradox. There's no center and there's no edge. But that cannot be true. That can be disproved logically. And to simplify that proof, I'll just state the result of the proof, that the final step is to be able to say that if the universe actually is unbounded going out, if it actually is infinite, then that's irrational. So therefore, and this would be, I would have to say this is actually philosophy unless it can be proved. Well, I have proved it, but you don't know that yet. So just hypothetically accept what I'm about to say, that the universe simply must be finite. But it also must be proved in order to say that scientifically, and I have the proof for that. The reason why it must be finite is because it has a center. And the other part of the paradox that needs to be cracked simultaneously to make the anti-paradox is that the center of the universe is not in one place. It's every place that there is a proton. So that definitely needs to be explained, or it's just a shot in the dark. But that's how I introduce this, because this is the way to get at the quantum paradox and, in fact, the cosmological paradox simultaneously. So I'm going to require you to use your mind as I explain this, because this is synthetic, which means we're going to unite two things, both of which have traditionally, historically been dicey to the point of being paradoxes. The outer infinity and the inner infinitesimal. That's where we can begin, because we can localize the infinitesimal. And therefore we only have one aspect of the paradox left. Why is it distributed? What can we say about the fact that the center of the universe is in uncountable numbers of protons? Is that a reasonable thing to say? Yes, spatially it is. So this introduces the most important dichotomy. And that is the difference between space and energy. It's not, strictly speaking, you could also say it's the difference between space and time. You could also say it's the difference between space and motion, or space and momentum. But the way the quantum was discovered was in the relation with energy, because it's energy that is quantized. And because energy can be said to be quantized, that is the basis of the quantum mechanical situation. It is paradoxical, but this is one way to describe the paradoxicality of infinitesimality. The fact that there is an inner limit to space. There's an inner limit that we can measure into which you cannot go. Nothing can go into a proton. And that is the definition of a particle in the unary sense. But what we actually do see is a two-particle relationship based on the proton. And the other particle in the two-particle system, the other particle, if we're being logically consistent in how we're classifying our terms here, organizing our terms, if I'm correct in saying that the proton is the spatial particle, because it bends space, now when we look at the electron, we're looking for a relationship. And it's phenomenal what this is. It's a genuine mind bender. But I hope you enjoy this. This is what I discovered. What I'm about to tell you can be proved. We're going to just introduce some terms. This is necessary at this phase of science, this kind of science, inductive science, synthetic, really pushing the envelope you are forced to invent terms. So we're going to borrow some terms that will be familiar, but I'll explain what I mean specifically by each term as I introduce them. Now, the two aspects of what we're doing by beginning at the center of the universe with the proton is that the proton is the spatial center of the universe, and to kind of dispel the fog of, well, wow, that doesn't make sense because it's not a single point on a sphere. Well, we just covered that, so what should we say instead? The proton is the spatial center of the universe. That's how we just said it. That's not enough to fully explicate it. The proton is the distributed spatial center of the universe. Let me say that again. This is hypothetical, but this is what I want you to go along with until I prove it. The proton is the distributed spatial center of the universe. You could also say it's the distributed center of space, which amounts to the same thing. It's a particle because it occupies a position in space. Now let's look at the electron. The electron never does what the proton does, and it definitely is not at all what the proton is. So what is the electron? And what we want is the relationship of the electron with the proton, right? So we begin by examining the cutting edge, what we actually know about the electron. You could say it's a lot. We know a lot about the electron and its behavior. But really, I'm just going to cut to the chase here. The electron is a manifestation of motion. The proton is not. And we're homing in now on the atomic system, because all atoms are composed with this spherical relationship where there is a center now. It's the center of a local space, which is the atomic space. How far does that extend? Well, you might as well ask, how far does the gravitational field of the solar system extend in space? You actually could find the answer to that, but it is paradoxical because technically it's infinite. It can be proved that, for instance, a star or a supermassive black hole or even a proton has an infinite range of centripetal force around it. However, that is not actually perfectly true. And the man who discovered that that is not perfectly true lived 250 years ago. His name is Boshkovich, and he discovered a force curve system that describes the atom. So we're going to now delve into the mathematics, geometry, and mechanics of the atom, because this will lead us to the solution of the quantum paradox. And forgive me, I haven't had any lunch yet, so I'm just going to have a little lunch right now. In case you want to know, it's Lagunitas IPA India Pale Ale. So the atom is not what Democritus really thought it was by name. But what Democritus was thinking of, that the Greeks could not possibly understand because they lived over 2,000 years ago, that the atom that Democritus was trying to envision or hypothesize as the building block of the universe, or the building block of matter, is actually the proton. And the proton can be said to be that building block because it's static. It doesn't manifest itself through motion. Instead, it manifests itself through centripetal force. so it exerts a force in space. We call it gravity at macroscale level, but they're identical, so you can accept that. Now, the electron has a specific geometric relationship to that center, the proton. So we're now talking about a hydrogen atom, which consists of one electron and one proton. What does the electron do? We know what the proton does. It creates the sphericity of the space around it, which becomes apparent at the presence of the electron. So what does the electron do? It moves. It moves in a spherical orientation around the proton. So that is the basic building block of the universe, is an impenetrable sphere. And that word impenetrable is a Boshkovichian term that needs to be adopted now at the forefront of physics, because he's right. It is impenetrable. The reason why that is a central issue, and it has been for centuries, Newton wrestled with this, Leibniz wrestled with this, and Boshkovich inherited both the calculus and the insights of those two extraordinarily great scientists. By the time Newton died in the 18th century, and then Leibniz died shortly thereafter in the first quarter of the 18th century, Rüger was just a little boy. But by the time Rüger became of age, he not only became a Jesuit Catholic priest, but he also became the foremost scientist in Europe, extraordinarily highly respected. One does not hear his name because he appeared in the shadow of Leibniz and Newton. But Rüger did not utilize the calculus in order to compose a force curve definition for the relationship between two particles. He was not specific about charge relationship between particles because it had not been discovered. And so it's all the more remarkable. Without knowing anything about electrodynamics and without knowing anything about the atom, but just working with the two concepts of continuity and impenetrability, both words of which appear on every page of his book, which I read, he actually transcended the calculus and employed a diagrammatic, that is a graphical solution called the Boshkovich force curve, which I've shown you in previous lectures, which you can consult if you haven't seen them. But the Boshkovich force curve accurately describes the shell system of an atom in terms of force balance. These would be two forces, repulsive and attractive. Repulsive and attractive. Actually, repulsive and attractive is a spherical relationship, and he knew that. But the diagram can be perceived and understood in a 2D projection on an algebraic curve. This will be centripetal and centrifugal force. However, it goes deeper than that. It's actually a relationship between space and time. But this word time, we're going to get to a more accurate definition of what time is through this geometry. But I want you to think of time in a new way. Think of it in relationship to space. The characteristic of space is that it has no characteristics at all. That was disproved by Albert Einstein. There is one characteristic to space that we're certain of now. It bends spherically under protonic centripetal force. That the force that the proton exerts is to bend space in toward itself. That is static, it's passive, and for the longest time, as I mentioned, and still to this day it's debated, is gravity a force? Well, yes, it is. But a word needs to be added to that. It's a spatial force. And now we turn our attention to the electron, which last seen in our last mental diagram is in a spherical orbit around the proton. Now you may know, and if you don't know, you will know now, that that orbit of that electron is the damnedest, strangest orbit. And it's no longer acceptable to physicists. They really prefer to see this as a paradox now because they're convinced it is a paradox. Is that the electron never really is in any one place. So we have a definition for that, and it's a very convenient definition. This is for understanding, so this is extraordinarily helpful. What you're seeing when you see the electron in its shell around a proton, it's a wave. It's not a particle, it's a wave. But it's curious that the electron can be measured as a freestanding particle just like the proton. Well, just like the proton, that's the only thing it has in common with a proton. In every other respect, measurable or surmisable, the electron is the exact opposite of a proton. It's never static. It doesn't form a center. It's hardly really there. It has no known radius. And when it's manifested in the atom, it's not a particle at all. It's a pure wave called a standing wave. This is a standing spherical wave. And that is one direct perception of the quantum paradox. That we have one particle that it forms a center to space, and the electron responds to that by going into its waveform in a spherical shell around the proton. The question is, why does it do that? What is that electron doing? We know what the proton is by a definition of what it does, which is to occupy a center of space and to create spherical space around it, which are saying the same thing by adding the concept of a centripetal force. So that's what the proton is. It's what it does. It manifests centripetal force, curvature in space. Now, what the electron does in relationship to the proton is there's a relationship, which is what I'm getting to. Once you know the relationship, you've got it. But we haven't gotten, what is that relationship? It's perpendicular. It's perpendicular. And you can conceive that, picture the proton right here. It's not a point, by the way. It's a thing. The proton does have a radius. Although it's a strange radius, as you can imagine, because what is it, just a solid, hard surface? No. But it is a delimitable surface to within a range so that the surface of the proton does not extend further than 0.8 femtometers. That's fixed. Physics, it's constant. For one proton and one electron, the electron always goes an exact distance spherically and manifests itself as a spherical standing wave. So what is that? If the proton is the static center to space, then the electron is the modal, that is motive or motile. It's the momentum aspect of reality. The proton is not, it has nothing to do with motion. That's why it's so difficult to conceive of gravity as being a force, because there's no motion involved. It has an effect on motion. and that's manifested by the electron. That motion is affected by space, and that shows up in the atom in the formation of these quantum shells, and they're called quantum shells because they have discrete averaged distances, and you have to say it that way because the electron is never in one place because it's a wave. It can't be in one place if it's a wave, because a wave is very difficult to say where it is. And that is the quantum paradox. So the key insight comes not directly from perceiving that this is the relationship between space and time, in other words, the space-time geometry. That is true, but it's difficult to prove. But what is much easier to prove is that it's the relationship between space and motion, which in the case of sphericity is called angular momentum. But you can see that now we have an overlap of two different concepts, because is the electron manifesting momentum? You would have to say so, because it's not in one place. It's really, it's statistically, according to quantum mechanic interpretation, which is forced on us by our linear perceptual system, is that this is a pure curve. It's a pure sphere. It manifests in a region which on an average is known, but it's only an average because there's a range, and there would have to be because a wave is not linear. So it's not even circularly linear or spherically linearizable. It's kind of a fog. It's a statistical fog that the electron, in a sense, just wraps itself around the proton, and that's what it is. It is that standing wave, which definitely is not a particle. So what do we mean when we say electron? We mean that when we can isolate an electron. We definitely can do that. We can fire them from guns. But what are we firing from a gun? Well, we're not firing a particle. But it has exactly one characteristic that it shares with a proton in terms of it being called a particle at all. And that's that it is delimitable in a region of space. The proton is delimitable to a region approximately 0.8 femtometers, which is quite, it's as accurate as we've gotten with any measurement, really, in this context. But the electron is inherently larger. And so you could say that electron that's in its spherical orbit, that's what it is? Well, it's bigger. So is it a particle or not? And that's the paradox. Is the electron a particle or not? Well, it has two states. When it's in the atomic system, it's a wave. What is it when it's fired from a gun? The answer is it's still a standing wave. But it's a standing wave without a protonic, there's no charge inside. The electron, we can see, this is actually gravity, but we call it charge. So that's a convenient term to use here, because it's plus minus. But really, we know that the spatial particle, the proton, curves space, so it's a spatial particle. Now I want to hypothesize something which I've already proved, but I'm introducing it to you now as a hypothesis. What if the electron is the time particle? Could that be said? What would it mean? How would we prove it? Can we even make a prima facie case? We can. the nature of centripetal force is that it appears in a sense passive because there's no motion. Centrifugal force is the opposite. It's pure motion with no real conception of a center. So let me rephrase that. Centrifugal force would go out through something, correct? We conceive that as space. That may not be the best way to conceive of what centrifugal force is. At the atomic scale, there is no centrifugal force until the electronic system, the system of shells of electrons that pile up, depending on the number of protons, there's a direct correlation. Disregarding the neutrons entirely, they're weird. But we'll get back to that later, but not in this lecture. Neutrons are very interesting. Well, let me just say something about what that neutron is. The neutron and the proton are almost exactly the same particle, and it was Gelman who discovered the exact relationship between the proton and the neutron. The quark system is a 2-1 harmonic, so it's essentially a little tiny ticking clock. But it ticks between the neutron state and the proton state. When it's a 2-1 like this, it's a proton. But when it's inverted, and this what used to be the one type of quark, and now there's two of them, and therefore there's one of the other, that's the other state. And that's 2, 1, transferring to 2, 1, 2, 1, 2, 1. That 2, 1, 2, 1, when let's say 2, 1 or 1, 2. If it's 2, 1, it's a proton, but if it's 1, 2, it's a neutron. So that's interesting. That there is this harmonic, but it induces two different types of particles, that is, two different centers. And there's a distinct difference in the behavior of the proton with respect to its harmonic conjugate, the neutron. They will spontaneously change into each other. And the process of a proton turning into a neutron, I believe, is called beta decay and depends on something called the weak force. I'm quite weak in that area because it's not pertinent directly to what we're after, but it is certainly an interesting aspect of subatomic physics that the neutron and the proton are two states of the same thing, but the proton exerts gravity. I shouldn't say that because the neutron, I told you, the neutron is weird. And I believe that it does exert gravity because there are such things as neutron stars. But what the proton exerts that the neutron doesn't is called charge. That it has an electromagnetic effect. So that's interesting aspect of the neutron. I'll try to come back to that when I know more about it, but quite frankly, I'm not sure I know enough about the neutron to speak at all accurately about it. But that is the nature of the core called the nucleus of the atom. We're considering it now strictly in terms of a proton, because if you have just one neutron, the electrons ignore it. And that's only due to the fact that it's a 2-1 harmonic instead of a 1-2 harmonic. So the difference in the quark harmonic, which manifests as either a proton or a neutron, the electrons ignore the neutron, but they don't ignore the proton. So that's why the proton is the center of space. The atom as a localized system proves that. So all of this gives us several clues as to how we might regard the electron. It does not seem to have anything to do with space, except in the aspect I just mentioned, which is somewhat paradoxical, that if one is willing to say that it's pure motion, then why is it bound? Why can we say there's such a thing as an electron at all? Well, it's because we can fire it from a gun, so it is a unit. An electron is a particle in this sense. So there are two definitions of the particle. One is the spatial particle, so how can we characterize the electron particle? Since it's obviously not the same as the proton, what's the difference? What I've discovered is that it is that standing wave without a proton. So you can have an electron just in free space. It's essentially looking for a proton. So they're antiparticles. But it's weird because an electron is attracted to a proton, but when it reaches a certain range, in the case of hydrogen, if this is a proton over here, and the electron accelerates toward it, but when it reaches the 1 femtometer range, it spreads itself out into a sphere. That is a perpendicular change of momentum. It changes from going straight. If my nose is the proton, and here comes the electron, it's coming straight for my nose, but when it gets to within, we'll just say an inch, it spreads out spherically and goes into a spherical shell. Well, that requires some explanation, because you're looking at the quantum paradox now, that this thing, which was a particle, turns into a sphere. It is a distributed particle in spherical orientation to the proton. Wow. What in the world is that? Well, Boshkovich has the answer. He did not compose this as space-time, but the diagrams he drew can be directly interpreted as a space-time diagram at the atomic level. We are seeing the difference between a space particle and a time particle, and the shortcut to perceiving this is to change the word time to a surrogate or replacement term. That time is really an effect. And it's an effect of what? It's an effect of motion. So time is an effect of momentum. And the two are inseparable. Time and motion are interpreted in terms of each other, as motion is only interpretable with a time component. It basically is manifesting time as motion. Motion and time are directly related. So what does that mean? Well, think of it as angular momentum. And there you have it. The electron is the manifestation of angular momentum to the same proportion that the proton is the manifestation of a center of space. These do not seem to directly correlate. That is, we don't seem to see the relationship between those two. But the relationship has been discovered by two different discoverers. Einstein proved in his linear formulation of space-time, to compute gravitational space was his goal, and he succeeded. He orthogonalized time with space. So the relationship between the proton in an atom and the shell that is an electron, in the case of the simplex hydrogen atom, that shell is perpendicular to centripetal force. Centripetal force can be conceived as a single line that comes from all directions. It's the integral line, you can accept that term. It's the integral line that comes from infinity and converges on a point. That is the definition of gravity. It's the definition of centripetal force, which is purely a spatial term. There's no motion involved anywhere. It's static geometry. And that's only saying half the story, which then makes no real sense until you introduce the electron, which explains what the proton is doing, and the proton conversely explains what the electron is doing. And you have to see this as a single thing. That is space-time. So the orthogonality is this, that as space is being bent in by the proton, you can think of that as a direct line. If you were to have a relationship between that proton and electron, the electron goes straight on a straight line towards the center of gravity. And the electron makes a beeline for the proton, intending to collide with it. It's being drawn straight towards the center of gravity, straight towards the center of the proton. But something magical happens to that electron when it reaches the 1 femtometer limit, which is what limit is that? We're getting to that. It's the limit of two related forces. Okay? So one of the forces being exerted is by the proton to bend space, and there's no motion. The electron is pure motion. It's a standing wave of energy. The electron is a quantum of energy in the sense that it's a unit. So, it's okay. I don't want to use the word. Quantum is an overused word. And quantum merely means a unit, but you have to know a unit of what. And that's part of the paradox, is a unit of what. Well, the electron manifests angular momentum. It's pure angular momentum. It's a standing wave. And so the electron is essentially a wave. It's a spherically oriented, spherically bound wave. But that's very hard to explain, because what's causing it to cohere? What makes energy cohere in an electron so that it's a spatial presence? It has a spatiality to it. It's somewhere. It's rather difficult to say exactly where, to the extent that we don't to this day know the radius of an electron. It literally cannot be measured. But it can be measured to within a range that it's more likely to be where it is than somewhere else. So that's the nature of a wave, is that you can't really think of it in terms of position. Well, then what can you think of it in terms of? Periodicity. And periodicity is a brand new data type. Periodicity is not linear at all. It's based purely on a repetitive motion, which means in a circle. So what you're seeing with the proton is the manifestation of a passive force. It's a spatial force that curves the space around it. But the electron is the manifestation of momentum, which can be conceived as a oscillation. It's an oscillator, but it has no moving parts. The proton does. It has a 3-quark system, which when it's a proton, it has 2 up and 1 down. These are 2 different kinds of quarks. It's a purely mathematical relationship, because the quark is already known. It's been proved that it's not a particle. It's something, but it's not a particle. Well, it's an oscillator. And the answer to the paradox of what is the electron, it is also an oscillator, but in such an opposite sense that it literally rips our mind in half, because the nature of the proton as an oscillator is purely spatial with nothing to do with momentum. Whereas the electron, as an oscillator, is a manifestation of momentum with no clear spatiality. That's a fair statement. And so why does the electron not have a clear spatiality? It's because it's a wave. And that needs to be explained in terms of a harmonic. And that's where it gets geometrically and mathematically engaging, because we can now seek to compute the relationship between the proton and the electron. Now, we already know that spherically geometrically, in spherical geometric relationship, they're perpendicular. And the reason for that is, in the manifestation of protonic centripetal force, you can think of it in two ways. Either they're concentric shells, whether continuous or not, which can be visualized as proceeding out in space as a spooky action at a distance is what it looks like to us, but it presents a spatial field where as you go in towards the center, there's a stronger and stronger force of attraction due to the curvature of space. And that's the nature of the curvature of space, is that it reveals this mathematical relationship, which is the square law, sometimes called the inverse square law, that gravity manifests algebraically as the square of the distance from the center. Okay, hold that thought. That's pure spatial, has nothing to do with momentum. It's just a static curvature of space due to centripetal force pulling space in. The electron is a manifestation of momentum as a standing spherical wave. It's pure motion. That's all it is. And that is what a wave is. There's no such thing as a static wave. There is such a thing as a standing wave. And that has to do with some very interesting basic relationships between numbers and geometry, that if you think of take a circle and consider it oscillating such that it turns into an ellipse and then withdraws and goes into an ellipse this way, that's a harmonic. And you can see that that forms a perpendicularity. What is this? What is oscillating? Well, the way it's described in most textbooks, I think I'm stating this fairly, is that an electron is manifesting an oscillation. The best I can say it is the oscillation of energy, and therefore energy is oscillating. And so, in fact, the electron is an energy particle. Energy being defined as a standing spherical wave. In other words, a spherical oscillator. Well, that puts it in the same bullpen or the same dugout with the proton. Now they have something to talk about because each of them is an oscillator. But that's where the similarity ends, because the oscillator that's inside of the proton is so static that when it oscillates, it turns into a neutron. And the neutron also can spontaneously turn into a proton by a slightly different process, but both of these have been proved to exist in nature. So the neutron and the proton are the manifestation of some kind of oscillation. It's the quark oscillation. But when they oscillate, there's different particles. It will turn into a different particle, and these are distinct particles that can coexist in the nucleus on a very interesting relationship. But when you just look at the proton, it's just dead in the water. It's not doing anything. Well, yes, it is. You just can't see it because nothing is moving. But if an electron gets near it and you watch the electron, it goes toward it and it increases its velocity on a square law. It's accelerating towards the proton. And when it reaches what you could call maximum speed, it's suddenly, but it's on a range, so it's not instantaneously suddenly, but over a very tiny range of on the order of 0.2 femtometers, it changes direction perpendicularly. So that the electron, as it's coming in as a standing wave, spreads out at this limit and goes perpendicular to its vector towards the center of the proton and goes into a spherical orbit which is perpendicular to its linear course. So that is a direct relationship between linearity and sphericity on a right angle. And now we get to the Boshkovich force curve that describes this accurately. On the basis of the relationship between the two forces involved, the electron is a manifestation of momentum, which can also be called motion, which is directly related to time. So you can call the electron the manifestation of any one of those things, but now we need to algebraicize it to capitalize on our insight that the electron manifests a perpendicular relationship with a proton. And that perpendicularity, you just saw it diagrammed. I hope you can visualize that as the electron speeds towards the proton, when it reaches maximum speed, it goes at a right angle and makes a sphere and stays there. And now it's happy. So we have two oscillators which do two entirely different things. What does the electron do? It doesn't bend space, we know that. It responds to the bending of space, though. In this most curious fashion. I just think this is ultimately fascinating. Wasn't that what you expected when you got into physics, that you'd have your mind blown? You don't want to blow it too much. You want to stay rational, otherwise you just go into la-la land. Whoa, make up whatever you want. So what is the electron? Well, one thing we know about the electron is that if it obtains an increase in energy, and how would it do that? How does an electron obtain an increase in energy? Let's just say, since we know it can happen, it does happen, we'll just say, okay, the electron experiences an increase in energy. This would be an electron, this would be the electron going around the proton, to make it simple. So what happens in one case where it gets more energy is when a photon comes in. And a photon is also pure energy, as you know. So the photon comes in, and what does it do? The photon, if it goes into range, and this would be at light speed, so this is difficult to measure, but it is absorbed by the electronic shell, that is the electron in its spherical wave state around a proton. And that's already interesting, but that makes the shell have more energy. And now, what it does, since it can't sustain that energy, but it does absorb it, we know that. And what it does is it shoots out another photon, and that reestablishes the balance of force. To the exact amount of energy that comes into the electronic shell absorbs it and then emits another photon of the same energy. That's simplifying, but in this case, this would be accurate. So, what is a photon? Well, obviously the photon and the electron are intimately related. What's the difference between the two? Well, the difference can be seen first by examining what the electron does, which it really doesn't do anything that we can say other than it just floats around in space. But if it gets close to a proton, we know what it does. It goes straight for it and then spreads itself perpendicularly into a spherical shell. So that's what an electron does. But at no time is it going out. Nothing goes out. Everything's being pulled in. The proton is already at the center, which is another aspect of a paradox, because doesn't the center have to have a center? That's the three quark system. That's as far as we've gotten, but I can go farther, but we have to take this logical step by logical step. The photon is merely a detached portion of the electron. Well, how do we know that? Because the photon does something that the electron does not. And what is that? Well, we say that it's emitted, but what do we mean by that? It's a spherical wavefront in free flight. It's actually in free fall, but it's not going in, it's going out. And that is anti-centripetal force, which we call centrifugal force. And that's the only out force that we've ever seen in the universe, to the exact proportion that the only in force we've ever seen is the force exerted by the proton. The only out force is that exerted when the electron produces a photon, which then goes literally out. Why? Why does it do that? There's no clear, immediate, intuitively obvious reason why it would go out, particularly in the fact that the photon goes out at a consistent speed. And that means that there's something that we're not seeing. That is the rotary component of the universe. It's the manifestation of motion to the same degree that gravity is the manifestation of bent space. As space bends in, the photon goes out. And those are the two balancing forces of the universe. I discovered that. Now, a discovery is not a scientific discovery unless it can be proved. And a proof